Student, good morning. I hope you all are safe and healthy at your home. Welcome in lecture number 18, paper number IC-10, unit 3. In previous lecture, we discussed about open cycle OTEC system. Now, in this lecture, we will discuss about closed cycle OTEC system. Closed cycle. Here, described diagram is closed cycle OTEC system. Closed cycle ocean thermal energy conversion requires a separate working fluid which receive and reject heat to the source and sink via heat exchanger, either boiler or evaporator and condenser. In open cycle, this type of requirement is not, so we use heat exchanger or boiler or evaporator and condenser. So closed cycle OTEC requires separate working fluid. Now the working fluid may be ammonia, propane or a freon group. Ammonia, propane or a freon group. The operating pressure of such fluid at the boiler and condenser temperature are much higher than those of water, approximately 10 kg per centimeter cube. It is very important point noted that the operating pressure of such fluids, ammonia, propane or freon group, at the boiler and condenser temperature are much higher than those of water, and approximately this pressure is 10 kg per centimeter cube. Such pressures and specific volume result in turbine. Those are much smaller and hence less costly than that use the low pressure steam of the open cycle. We use in open cycle low pressure turbine. With comparison of open cycle OTEC and closed cycle OTEC, the pressure and specific volume results in turbine. Those are much smaller and hence less costly there that use the low pressure steam of open cycle. The closed cycle also avoid the problem of evaporator. Sometimes in open cycle, flash evaporators create the problem. So in closed cycle, it is also avoided. It requires the use of very large heat exchanger because of the additional higher efficiency. It has large heat exchanger. In figure, this is the large size evaporator or heat exchanger. So heat exchanger gives additional higher efficiency. The temperature difference in the boiler and condenser must be kept as low as possible. It is also very important point. The temperature difference in boiler and condenser must be kept as low as possible to allow for the maximum possible temperature difference across the turbine. This is the introduction and main application with compared to open cycle OTEC system. Now we discuss the mechanism of this type of plant. First of all, hot water or a warm water of sea surface is taken into evaporator. We describe here the temperature of surface water is 26 to 29 degrees Celsius. So this is the warm water. It take in evaporator with the help of warm water pump. Now in evaporator there are many evaporators which converted the heat into high efficiency, and here our Rankine cycle or low boiling component are evaporated. Ammonia, freon, etc. compound vapor is flash vaporized in evaporator, and this mechanism is converted large heat. So the efficiency of this type of evaporator is very high. Now this flash vapor of refrigerant are passed into turbine which converts heat energy into mechanical energy, and this type of turbine is joined with condenser, joined with generator which generate electric powers. Now the low efficient vapor is converted or pass into condenser where it is condensed and form in liquid state. So condensate are condensed in condenser. Now this liquid is continue in evaporator and then in turbine condenser. So here is a closed system. For condensing system, here we use deep cold water and its temperature is around 4 to 8 degrees Celsius. 4 to 8 degrees Celsius. According to some of experiments and reading, the depth is 1000 meter. So surface water and at a depth of 1000 meter, the ocean water has temperature difference. Here we noted surface water has 26 to 29 degrees Celsius and 800 to 1000 depth, the water temperature is 4 to 8 degrees Celsius. So this type of waters we use in closed cycle system. This is also a schematic diagram of closed cycle system. Here we use surface warm water at 26 degrees Celsius and depth cold water at 1000 meter. Depth cold water contains 5 degrees Celsius temperature. So temperature difference between warm surface water and depth cold water, we get electricity by this type of closed OTEC system. This is also a second diagram for the closed OTEC type system. This is also a one of closed type of OTEC system. This is also a schematic diagram for the closed type OTEC system and power generating plant from ocean thermal energy. This is also a closed cycle OTEC system. This is also a closed cycle OTEC system. We see mechanism in this type of working plant. The intake water is around 25 degrees Celsius. Surface warm water is at 25 degrees Celsius, which take in evaporator, and in evaporator there are one cycle is continued, and this 20 degrees Celsius temperature is converted it into 23 degrees Celsius. So the working fluid vapor is at 23 degrees Celsius, which is passed into turbine or generator, which generates the electricity. And here we show the temperature difference. The input flash vapor is at 23 degrees Celsius, while output in turbine it is only 11 degrees Celsius. So this temperature converted into mechanical energy and we get electric power. Now this 11 degrees Celsius, the fluid vapor is in both state, gaseous and liquid. So, and their efficiency is not high. So, we converted into liquid form in condenser, and in condenser we use cold water, that is from depth 9 degrees Celsius cold water, which is convert 11 degree vapor into 7 degree liquid form. So with the help of warm surface water and deeper cold water, without any energy consumption, only we get this type of temperature from surface and depth of ocean. So it is our non-renewable very important source for our energy consumption. But there are only one problem, which is the temperature difference. According to earth formation, every oceanic water have not difference of 25 to 29 degrees Celsius. So everywhere where ocean water is available but the temperature difference is not, then we do not use this type of energy by open cycle or a closed cycle. I have some videos of this type of systems which are attached here. Please see the video. Ocean thermal energy conversion. we get electricity by this type of different energy sources, renewable energy sources, wind energy, oceanic wave energy, and we discuss as this type of surface water, ocean thermal energy conversion system. Temperature difference, and this is the situation of our earth where hot surface water is take in evaporator which evaporate the different type of refrigerants and we get electric power. This is the second OTEC system. Surface water at 25 and depth water is at 5 degrees. So we get this temperature difference and we establish OTEC system. Open cycle and closed cycle. Surface water and 1000 meter depth. Depth water is cold and surface water is hot. This type of mechanism is developed at 100 degrees temp depth we get cold water. This is also another plant or emanation video how it work OTEC. Surface water and depth cold water. These are the basic requirement of OTEC. This is ammonia cycle OTEC power plant. Ammonia is vaporized in evaporator and then it pass into turbine and turbine joined with generator which produce electricity.